Right now, as we're speaking on August 15th, 2026, one of the most historically significant and rare meteorological events is unfolding across the Pacific. A tropical system that hasn't been seen in this particular context in over a century is on a direct collision course with the Hawaiian Islands, and meteorologists across the region are closely monitoring this extraordinarily unusual setup. The system in question is Tropical Storm Lala, currently packing sustained winds of around 60 miles per hour and strengthening as it moves westward through the central Pacific toward the Big Island of Hawaii. But here's what makes this system so exceptionally rare and dangerous. If Lala makes landfall on the Big Island as a hurricane, it will represent the first direct hurricane strike on that island since 1871. That's over 150 years without a direct hit from an intact hurricane. Think about that for a moment. The Big Island's massive volcanic peaks have historically shredded approaching tropical systems, tearing them apart through topographic interaction and creating a natural barrier that has protected the island through the modern meteorological era. Until now. The National Hurricane Center has issued a hurricane warning for Hawaii County, which covers the Big Island, and tropical storm warnings have been extended to parts of Maui County as well. This is not a grazing blow or weakening system limping toward land. Forecasters are expecting Lala to reach hurricane intensity before it reaches the islands, potentially climbing to Category 1 strength with sustained winds of 75 miles per hour or higher. The current track has the system either grazing or making a direct landfall on the Big Island around Saturday, August 16th, bringing what could be once-in-a-century impacts to one of America's most geologically active and vulnerable regions. The rainfall forecast alone tells you everything you need to know about the danger this system represents. Across Maui and the Big Island, residents are facing expected rainfall totals between 8 and 12 inches. But that's just the baseline. In steeper terrain, in the vulnerable valleys and coastal foothills, where rainfall efficiency is maximized by the topography, isolated maximum totals could reach as high as 25 inches. That's over 2 feet of rain falling in a matter of hours on islands that aren't accustomed to receiving that kind of moisture delivery from a tropical cyclone. This kind of rainfall presents a severe, life-threatening risk of flash flooding. The Big Island's drainage systems, while functional, weren't designed for this kind of atmospheric river-like delivery. We're talking about rapidly rising water that could sweep through normally dry gulches, overwhelm stream channels, and inundate coastal lowlands within minutes. Beyond the flooding threat, mudslides and debris flows become inevitable when you're dropping that much rain on steep volcanic slopes. The mountains that make Hawaii so beautiful also become liability zones when that kind of moisture is forced up and over them by a hurricane-strength wind field. The storm surge component adds another layer of danger that gets overlooked in discussions focused on wind and rain. Forecasters are predicting a dangerous storm surge between 1 and 3 feet, which means the ocean itself is going to rise and push inland, flooding areas that normally stay dry and potentially undermining buildings, infrastructure, and roads that are too close to the coast. This surge combined with heavy rain creates compound flooding scenarios where rivers are already overwhelmed. The ocean is pushing back from the other direction, and the normal drainage routes are blocked or saturated. The coastal areas around the Big Island, despite being relatively less populated than Honolulu on Oahu, still contain homes, businesses, and critical infrastructure that could be compromised by this combination of threats. The storm surge in a hurricane context isn't just high tide. It's a wall of water that's pushed ahead of the storm by the wind field and driven upward by the pressure deficit beneath the eye. It can overtop coastal roads, breach seawalls, push salt water into freshwater aquifers, and fundamentally alter coastal geography. For a Big Island community accustomed to normal tidal ranges and occasional high surf events, a 3-foot surge combined with heavy rainfall and strong winds represents unprecedented stress on coastal systems. Lala is also a wind threat of significant consequence. Those 60-mile-per-hour winds we're seeing now are forecast to strengthen to hurricane force. The Category 1 hurricane brings sustained winds of 74 to 95 miles per hour, which means roof damage, power outages, trees snapped at the trunk, and flying debris becomes a genuine hazard. The Big Island doesn't see this kind of wind regularly. Most of the infrastructure was built with different wind design standards than what hurricanes require. When you're looking at sustained hurricane force winds over hours, the cumulative impact on buildings is severe. Older structures simply aren't designed to withstand this. Roofs tear off. Windows and doors fail. Interior pressures build up that push walls outward. Mobile homes are particularly vulnerable. They offer almost no resistance to hurricane force winds. Even well-constructed homes can sustain damage when winds exceed 90 miles per hour for extended periods. Power lines will come down. Some estimates suggest that 90 to 100% of power customers in affected areas could lose electricity. Generators will be critical for hospitals, water treatment plants, and emergency services, but not every facility has them or has them adequately fueled. Hospitals and emergency services will be strained dealing with injuries from the storm itself, trauma from flying debris, injuries from trying to secure homes during the storm, and medical emergencies in people who are already under stress and without power for medical equipment. Communication could become difficult or impossible when cell towers are damaged or lose power. The wind itself becomes a life safety threat during the strongest bands of the storm, and being outside is essentially suicidal if speeds exceed 90 miles per hour. There's also a wildfire concern that makes this situation even more complex. While it seems counterintuitive to worry about wildfires when you're expecting over a foot of rain, the issue is the timing and the wind. Before the heaviest rain arrives, Lala will bring strong winds with lower moisture content. These winds could potentially spread existing fires or ignite new ones in vulnerable areas. Hawaii's wildfire seasons have been severe in recent years, and the combination of strong winds ahead of the main rain shield is a real operational challenge for emergency managers trying to stage resources and keep populations safe. The historical rarity of this event cannot be overstated. The Big Island hasn't experienced a direct hurricane strike since 1871. That's the Civil War era in American history. That's before the Hawaiian Kingdom was formally overthrown. That's before Hawaii became a U.S. territory. That's before modern meteorological observation networks existed. No one alive today has experienced this on the Big Island. No infrastructure has been battle-tested by a direct hurricane. The emergency management systems have been developed, refined, and tested against hypothetical scenarios, but the real thing brings complications and challenges that simulations can't fully capture. Hawaii's authorities have been preparing shelters, urging residents to secure their homes, stock emergency supplies, and prepare for the worst-case scenario. The situation is being treated with the utmost seriousness because everyone involved understands the historical significance and the genuine danger this represents. But this story doesn't end with Hawaii. While Lala represents an extraordinary and rare threat to the islands, the broader atmospheric pattern across the North American continent is also producing significant, severe weather threats that deserve close attention. The same large-scale pattern that is directing Lala toward Hawaii is also creating substantial instability and wind shear across the mainland United States. This is how global atmospheric circulation works. Weather systems don't exist in isolation. They're all part of a connected web of atmospheric processes where changes in one location cascade into changes elsewhere. The Storm Prediction Center, the official arbiter of severe weather risk in the continental U.S., has been monitoring these threats closely and has issued a series of convective outlooks for the next several days that outline multiple areas of concern. These outlooks represent the consensus opinion of experienced meteorologists who've studied the model guidance, analyzed the atmospheric data, and made informed professional judgments about where and when severe weather is most likely to develop. For today, August 15th, 2026, the Day 1 outlook from the SPC shows a marginal risk of severe storms across portions of the forecast domain. This marginal risk category is the lowest official category on the 5-tier severe weather risk scale. But even marginal risks can produce significant impacts. Marginal risks typically mean that if severe weather does develop, it will be scattered and isolated rather than widespread. But the storms that do develop can still reach severe criteria with large hail, damaging winds, or isolated tornadoes. The real severe weather attention for the next few days is focused on the Day 2 and Day 3 outlook periods. For August 15th into the 16th, the SPC has issued a slight risk of severe storms across the central high plains and a broader area stretching from the Ohio Valley southeastward into parts of the Carolinas. This is a significant upgrade from the marginal outlook and indicates confidence that severe weather will develop somewhere within this region. The primary threats outlined by the SPC are damaging winds and hail, with a low tornado probability around 2% in some areas. Damaging wind events can be deceptively dangerous. When we talk about damaging winds in a severe weather context, we're typically discussing wind gusts of 58 miles per hour or higher. At that wind speed, roofs sustain damage, large branches break from trees, mobile homes are overturned, and debris becomes a dangerous projectile. Over the past few years, damaging wind events have caused more overall damage to property and infrastructure across the U.S. than tornadoes. A derecho, an extremely powerful organized wind event associated with a squall line, can cause damage comparable to a strong tornado across a swath hundreds of miles long. The upper Midwest, Illinois, and Indiana experienced exactly this kind of event just a few days ago on August 11th, 2026, when a derecho-like system swept across the region with high winds, causing significant damage and power outages. That recent event is a reminder of how quickly severe weather can develop and impact large areas. The current setup for the next few days has similar ingredients to what produced that derecho. There's abundant moisture, instability in the atmosphere, strong wind shear, and multiple boundaries and triggers that could produce organized convection. The SPC has specifically highlighted mesoscale convective vortices, or MCVs, as potential initiation mechanisms for Day 2 and Day 3. An MCV is basically a low-pressure center that develops within the trailing stratiform rain shield of a decaying thunderstorm complex. Now, when new storms develop on or near an MCV and interact with it, they can rapidly intensify and produce severe weather. Additionally, surface boundaries, the lines where air masses with different properties collide, are expected to play a key role in storm development. These boundaries can focus storms and allow them to organize into more efficient and dangerous modes. Residual moisture from repeated heavy rainfall over the Midwest and Ohio Valley is also playing a role in this pattern. The region has been experiencing multiple rounds of rain and thunderstorms over the past week or so, leaving soil moisture very high and the lower atmosphere quite humid. When dry, unstable air from elsewhere in the country interacts with this high moisture environment, it can create explosive instability and rapidly developing thunderstorms. The combination of all these factors, moisture, instability, wind shear, boundaries, and MCVs, creates a potent recipe for organized severe weather. The SPC's slight risk for Day 2 and Day 3 reflects this combination of threats. For Day 3, which would be August 16th into the 17th, the SPC has outlined a slight risk in parts of the Mid-Atlantic and Central High Plains. This continues the threat for severe weather, but with a smaller area of concern and presumably lower overall confidence than the Day 2 period. For Days 4 through 8, the predictability decreases significantly. Forecasters have much lower confidence in specific storm timing and location beyond the Day 3 window. There is some potential for additional severe weather during this period, but no high-confidence widespread outbreak is currently highlighted. This is typical in extended outlooks beyond the 3-day period where computer models begin to diverge and uncertainty increases substantially. The further ahead you try to forecast, the more the small differences in initial conditions and model physics lead to vastly different outcomes. A weather model that's exquisitely detailed and accurate for a 3-day forecast might be essentially useless by Day 8. This is the nature of chaotic systems like the atmosphere. Forecast uncertainty grows exponentially with time. The broader context for this severe weather pattern involves a region of heat that has developed across the southern United States. A massive heat wave is bringing heat indices of 105 to 115 degrees Fahrenheit across parts of Texas, Louisiana, Oklahoma, and neighboring states. When you combine this extreme heat with the moisture from the Midwest and Ohio Valley being transported southward by atmospheric currents, you create conditions of very high instability. The air becomes unstable to extreme levels, meaning that if you can trigger it to rise through heating or boundary interaction, it will continue rising and cooling, releasing tremendous amounts of latent heat and producing strong updrafts that can support severe thunderstorms. The combination of repeated heavy rain in the Midwest, extreme heat in the south, and strong wind shear aloft creates a pattern that meteorologists recognize as historically productive for severe weather. This isn't a one-day event and then everything calms down. This is a multi-day severe weather pattern that could produce impacts across a large swath of the country. Individual storms within this pattern could be significant. We could see organized wind events that create damage over hundreds of miles. We could see large hail, in some cases golf ball sized or larger. We could see isolated tornadoes, particularly where wind shear is most pronounced. Flash flooding could occur where storms train over the same areas repeatedly or where topography forces additional moisture upward. The geographical areas most at risk include parts of the central and northern high plains, the Midwest from Minnesota down through Missouri and Illinois, the Ohio Valley covering parts of Ohio, Indiana, and Kentucky, and extending southeastward into the Appalachian region and the Carolinas. This is a large area, and not every part of it will experience severe weather. The pattern will likely produce localized pockets of significant impacts while other areas see little to nothing. This is the nature of severe weather forecasting. You can identify the regions where conditions support development, but pinpointing exactly where the strongest storms will form is nearly impossible beyond a few hours. Now, let's shift our focus across the Pacific to another significant weather threat that's receiving less attention in the mainstream media, but which affects a very large population and represents a significant concern for flooding and infrastructure damage. The Pakistan Meteorological Department has issued forecasts and warnings for an active monsoon threat across Pakistan, particularly affecting upper and central regions of the country. The current situation involves moisture-laden air masses interacting with topographic features, particularly the mountain ranges that define much of Pakistan's geography, creating conditions favorable for heavy rainfall. The PMD is specifically warning of substantial rainfall and thunderstorms across upper and central Pakistan, with the potential for heavy rainfall in vulnerable areas that could produce urban flooding and riverine flooding. This is a particularly acute concern in low-lying areas and urban zones where drainage infrastructure is already stressed, and where rapid runoff can create dangerous flood conditions very quickly. The areas under specific flood watch and advisory include Islamabad and Rawalpindi, the twin cities that serve as Pakistan's capital region and home to millions of people. These cities sit in a foothill zone where water drains toward central collection points, and heavy rainfall can overwhelm urban drainage systems. Mardin, Swabi, and Gujranwala are also mentioned as vulnerable areas where urban flooding is possible. Gujranwala is one of Pakistan's major industrial centers, and flooding there could impact manufacturing facilities, create disruptions to commerce, and pose safety risks to the population. The combination of urban development that has reduced infiltration through paving and reduced permeability, along with drainage systems designed for normal rainfall patterns, creates vulnerability during monsoon events. When you add heavy rainfall on top of already saturated soil from previous rainfall, you get flash flooding. The Pakistan Meteorological Department's Flood Forecasting Division is providing real-time monitoring of river conditions and issuing flood bulletins and warnings as conditions develop. They're tracking rainfall accumulation, river stage levels, and forecast runoff to provide the earliest possible warning of flood threats. The National Disaster Management Authority of Pakistan has also issued weather advisories alerting the population to prepare for the rainfall event. These advisories are the front line of defense, giving people time to prepare, move valuables to higher ground, and potentially evacuate if necessary. These South Asian monsoon events can be extremely prolific in their rainfall production. When the southwestern monsoon wind pattern interacts with the eastern flank of mountain ranges, it's forced to rise, expand, and cool, causing tremendous amounts of moisture to precipitate out. The phenomenon is called orographic enhancement, and it can produce rainfall rates that are difficult for drainage systems to manage. A location that might typically receive several inches of rain over an entire month can receive that much in a matter of hours during an active monsoon event. The physics is straightforward but powerful. Air carrying moisture at the surface is forced upward by the mountain barrier. As air rises, pressure decreases, and temperature drops at a known rate called the adiabatic lapse rate. As temperature drops, the air can no longer hold as much moisture, so condensation occurs and precipitation develops. The more moisture in the air and the greater the upslope forcing, the more intense the precipitation becomes. This is why the windward slopes of mountains in the tropics receive some of the highest rainfall totals on Earth. The Hawaiian Islands experience this same orographic effect, and the Big Island's mountains will force Lala's moisture aloft, intensifying rainfall on the windward slopes. The human cost of severe monsoon flooding in South Asia has been historically very high. Flooding can displace thousands of people, destroy homes and agricultural land, damage roads and communication infrastructure, and create disease vectors and sanitation challenges. The Pakistan meteorological community and disaster management agencies are actively working to communicate the risks to the population so that preparations can be made. The timing of this monsoon threat is interesting in that it occurs simultaneously with the Hawaii and mainland North American severe weather patterns, reminding us that extreme weather is a global phenomenon happening across multiple regions at the same time. The historical context of these events is also worth considering. The Big Island of Hawaii hasn't experienced a direct hurricane strike in 155 years, which means that today's buildings, infrastructure, and systems have never been tested by this kind of event. Modern hurricane-resistant building codes exist, but not every structure on the Big Island was built to those standards. Many homes and businesses were constructed before modern building codes were implemented or updated. Emergency management systems have been developed and refined through training and planning exercises, but the real event will present challenges and complexities that even the best preparation can't fully anticipate. Plans look perfect until reality introduces variables that no one anticipated. The coordination of resources, the routing of people to shelters, the triage of medical emergencies, the restoration of essential services, these all become exponentially more difficult when the stakes are as high as they are with a direct hurricane strike. Similarly, the U.S. severe weather pattern expected over the next several days is reminiscent of historically productive patterns that have generated significant events in the past. The August 11th derecho serves as a reminder that strong wind events can develop quickly and cover large areas. That event caused significant damage with high winds lasting for extended periods, creating impacts that were felt across multiple states. The combination of ingredients currently in place, moisture, instability, wind shear, and boundaries, is well understood by meteorologists as a setup that frequently produces significant severe weather. When all these ingredients align, the probability of severe weather isn't a question of if, it's a question of where and how strong. The Pakistan monsoon represents a recurring seasonal pattern, but within that pattern, variation occurs. Some monsoons are exceptionally wet and produce extreme flooding, while others are closer to average. The current forecast suggests that this will be a significant monsoon event with rainfall well above normal. The monsoon rains are also essential for agriculture in Pakistan, as they provide much of the moisture that sustains the growing season for crops. However, when the rains are excessive, they create flooding and destruction that can wipe out the very crops that the monsoon is supposed to support. It's a delicate balance between having enough rain and having too much. Looking at the broader atmospheric pattern, all of these events, Lala in Hawaii, the severe weather pattern across North America, and the monsoon in South Asia, are connected through large-scale atmospheric dynamics. The jet stream position, tropical and subtropical ridge configurations, areas of upper-level low pressure, and the overall circulation patterns that dominate the global atmosphere in mid-August 2026 are all linked. Changes in one part of the world's weather can have downstream effects thousands of miles away. The pattern that's directing Lala toward Hawaii is part of the same large-scale circulation that's contributing to instability across the mainland U.S. The monsoon winds affecting Pakistan are driven by temperature gradients and land-sea interaction on the Asian continent, but these are also influenced by global atmospheric circulation patterns. For people in Hawaii, the message is clear: preparation is essential. The next 24 to 48 hours are critical for securing homes, gathering emergency supplies, charging electronic devices, ensuring medications are stocked, making arrangements for vulnerable family members, and understanding evacuation routes and shelter locations. Once Lala's outer bands begin affecting the islands, conditions will deteriorate rapidly. Wind will increase, rain will intensify, visibility will decrease, and the danger posed by falling trees and debris will increase. Staying indoors during the height of the storm is the safest course of action. If you're in an evacuation zone, leave before conditions deteriorate. Don't wait until conditions are obviously dangerous. By then, roads may be impassable and you may trap yourself. Prepare now, while you can move freely and safely. Store fresh water. Have food that doesn't require refrigeration. Know where you'll shelter if evacuation is necessary. Check on elderly neighbors and ensure they have resources and support. Make sure pets have carriers and identification. These preparations, taken seriously, can be the difference between weathering this storm safely and facing genuine danger. For people in the mainland United States in the affected severe weather areas, the message is to stay weather aware over the next several days. Check the latest SPC outlooks regularly. Pay attention to local National Weather Service offices that provide more specific guidance for your area. Have a plan for how you'll respond if severe weather develops. Keep away from windows during severe thunderstorms. Be prepared for power outages, which could result from damaging winds or lightning strikes. Have flashlights, batteries, and alternate power sources ready. For people in Pakistan, the advisory from the meteorological and disaster management agencies should be taken seriously. The potential for urban and riverine flooding is real. Understand your area's flood risk, know evacuation routes, keep emergency supplies on hand, monitor local weather advisories and flood warnings. Don't attempt to cross flooded roads or streams. Moving water is deceptively strong, and even shallow-looking water can sweep vehicles downstream. The technology of weather forecasting has advanced tremendously in recent decades. Satellite imagery gives forecasters a continuous view of cloud patterns and storm development. Weather radar allows monitoring of precipitation intensity and storm structure. Atmospheric soundings provide vertical profiles of temperature and moisture. Computer models integrate all available observations and use the laws of physics to project how weather systems will evolve. The SPC's convective outlooks are produced by experienced meteorologists who study these tools and synthesize information into risk assessments. The National Hurricane Center's forecasts for Lala are based on decades of hurricane forecasting experience and improved understanding of tropical cyclone dynamics. The Pakistan Meteorological Department's rainfall forecasts are grounded in understanding of monsoon mechanics and how moisture interacts with topography. Yet, despite all this technology and expertise, uncertainty remains. Computer models don't agree perfectly. Rare events have limited historical examples to draw from. Small-scale processes that individual thunderstorms use to organize can't be predicted days in advance. This is why forecasters present their products as probabilities and ranges rather than certainties, and why it's so important for the public to stay informed through the forecast period and as new information becomes available. The August 15th, 2026 weather situation represents an interesting and significant moment in the weather calendar. Multiple significant threats are active simultaneously across different parts of the planet. In Hawaii, a historically rare hurricane threat. Across the mainland U.S. topping a multi-day severe weather pattern with all the ingredients for significant impacts. Across South Asia, a monsoon event with flooding potential. For meteorologists, weather enthusiasts, and emergency management professionals, these are the kind of situations that define the field. These are the moments when forecast accuracy matters, when preparation pays off, when the science of understanding atmospheric dynamics proves its value. For the general public in affected areas, these situations demand attention, preparation, and respect for the power of weather. Nature operates on scales we can observe with modern technology, but her power is immense. Getting out of the way of a rare severe storm is the wisest course of action. Whether that's staying indoors during a hurricane in Hawaii, sheltering from severe weather in the U.S. Mars, or moving to higher ground in flood-prone areas of Pakistan, respecting weather threats saves lives. As we continue through August 15th, 2026, monitoring these situations remains essential. Official forecasts will be updated as new information arrives. Computer models will be rerun with the latest observations. Meteorologists will refine their understanding of how these systems will evolve. For people in affected areas, staying informed, following official guidance, and taking preparation seriously is the best course of action as a rare severe storm scenario unfolds across multiple regions of the world. The convergence of these multiple weather threats, a rare hurricane threat to Hawaii, a significant severe weather pattern across the mainland United States, and an active monsoon threat across South Asia, reminds us that extreme weather is a global phenomenon that respects no borders and affects millions of people simultaneously. The weather system doesn't care about political boundaries or economic status. It delivers its impacts based on physics and atmospheric dynamics. Our job is to understand those physics, communicate the risks clearly, and help people prepare and respond appropriately.